Now, so hydrocarbons, okay, we are going to learn about two, okay, which is going to be alkane and alkene. We are not going to learn about alkyne, okay, carbon-carbon triple bond, because they are not in our syllabus, okay. So alkane and alkene. Now, alkane, they are known as saturated hydrocarbon, okay. What is hydrocarbon? A compound that has hydrogen atom and carbon atoms only, okay. So that is hydrocarbon. So this saturated alkane, okay, generally we have alkane, they have single bond like this. So if you look at each carbon atoms, they have total of 4 bonds. Because of the 4 bonds, we say the carbon is sp3 hybridized. Yeah, I told you to go and read about this. Yeah, sp3 hybridized, because you need 4 orbitals. So you have 1, 2, 3, 4, 4 orbitals as well. Okay, so sp3 hybridized. Alkene, on the other hand, they have carbon-carbon double bond. Therefore, they have total of 3 bonds. One sigma here, and another one is pi. So total of 3 bonds surrounding that carbon. So if it is 3 bonds, you need 3 orbitals. Therefore, it's going to be sp2 hybridized. So please remember, alkanes are called saturated hydrocarbon. Alkenes are unsaturated hydrocarbon. Why they call unsaturated and saturated? Saturated means cannot undergo addition. Okay, there is no more further bonds can be formed, okay, for saturated. But unsaturated is not saturated yet, so you can still form bonds. Okay, and we have learned that, okay, if you form new bonds, these are going to be known as addition reaction. If you have saturated situation, you cannot form new bonds, you have to replace. When you do replacement, that is called substitution. So we are going to look into detail about that. So when talking about sources, where do you get hydrocarbons? You get hydrocarbons from crude oil. Okay, what is crude oil? Okay, it's a complex mixture of hydrocarbons. Okay, and then this mixture of hydrocarbons, okay, it's going to be, you have a mixture of what? You have a mixture of alkanes, you have cycloalkane, you also have aromatic compound. Okay, alkanes, you know, all the carbon and hydrogen, and most of them, okay, in crude oil, they exist in a very long chain. Okay, very long chain. And then cycloalkane, okay, example will be maybe 4 carbon, they join together like this. Okay, this is going to be cycloalkane. And then we have different combination, they are going to be linked together. And aromatic compounds, okay, aromatic compounds is any compound that has this benzene ring structure. Okay, so if you have this benzene ring structure, we call them as aromatic compounds. And why they give this term aromatic compounds, I think I mentioned to you earlier. I do not know why in Indonesia we call it the petrol as benzene, bensin. Okay, but maybe the original situation exists because, okay, petrol contains aromatic compounds, which is benzene, Zene. So I do not know, maybe the Indonesians in the past, okay, they confused that. Okay, they use the term benzene, okay, to represent petrol. But if you go to other countries, we don't call it benzene, we call it as petrol. Okay, but the reason why they it's a good thing when they use benzene is you can relate to them easier. Why? Because benzene, okay, they are aromatic compounds. And if you smell petrol, it gives you a very strong smell. Some people like it, some people don't like it. But that smell is an aromatic smell because we add benzene into petrol. Okay. And that is going to be the smell of petrol is caused by the aromatic compound, which is the benzene. Okay, which is the benzene. Anyway, let's look at the general formula. Okay, the general formula. So you see crude oil, you can have all this. Okay, so I put alkane. Alkane, we have already learned about this general formula, CnH2n plus 2. Cycloalkane, on the other hand, they are related to these two, okay, which is cycloalkane and alkene. They have the same general formula. Therefore, I told you, when you look into the functional group isomerism, you always consider alkene, there might be cycloalkane. Okay, so anyway, the general formula is going to be CnH2n. And the aromatic compound, okay, I just put it over there. There will be presence of benzene ring, and we will learn more about this in A2. Okay, so I'll just put it aside first. Okay, now, so let's actually look into crude oil. Okay, when you collect crude oil, okay, generally you get the crude oil. Okay, we get it to the surface of at oil wells, and after that we transport to oil refinery. Why we need to refine the oil? Because if you look at crude oil, you cannot use them directly. It's a mixture. So you need to separate them, okay, using a process what we call as fractional distillation. So if you have fractional distillation, it's like something like when you do fractional distillation, but in a bigger scale. So we use fractionating columns, okay, and I put a diagram of that. This diagram should not be something that is very new for you. You would have seen this many times already. But I want you to always recall this, okay, whenever you have a fractional distillation, a fractionating column, okay, maybe it's not important to memorize everything. Okay, maybe it's not important. Okay, but you need to know the temperature. Okay, the temperature generally when you go up, okay, the temperature is lower. When you go down at the bottom, because that's the furnace, that's where heating happens. Okay, that's going to be the part that is going to be the hottest. Okay, so the top, okay, and then the bottom. So when you have, okay, a boiling point, for example, when you go up, okay, the boiling point of the compound that is being collected is going to be boiling point is lower, and the compound that is being collected at the bottom is going to be the boiling point that is going to be higher. Okay, for example, bitumen, okay, you use it for making tar on the road. So the boiling point, okay, of tar, okay, is going to be very, very high. And you can see it can be separated into many parts, like for example, fuel oil for ships, diesel, and then paraffin, naphtha. A lot of is a starting compound for a lot of chemicals. And then the high demand, the one that we always use will be the one that is going to be gasoline, petrol. Okay, this is the one that we always use, and we always use. Okay, I don't know whether you can. Okay, sorry guys. So I will continue again here. The one that we are going to always use is going to be the gasoline, okay, or the petrol. And the one that we always use also going to be the petroleum gas, okay. These are the one, okay, we call it as LPG, or in your Bahasa, they call it LPG, okay. So that is going to be something that what is LPG? Let's see whether you guys know what is LPG. Nevan, do you know what is LPG?
Petroleum gas.
Yeah. Okay, it's a petroleum gas, so which is going to be liquefied, okay, liquefied petroleum gas. So Indonesian change it into LPG. Okay, so basically it's LPG. Okay, liquefied petroleum gas. So this liquefied petroleum gas is used for cooking, and gasoline is going to be used. So do remember, when you have crude oil, okay, when you separate them into many parts, okay, you the one that we always use is the one that is going to be the boiling point that is lower. So we cannot use the crude oil as it is. Okay, it's quite difficult, okay, to use, because it's don't have any use if you do not do fractional distillation. So therefore fractional distillation is very, very important. Okay, I know my connection is not so strong. Let me place my modem somewhere else. Okay, hopefully it becomes better. So anyway, you see here, okay, so I put it over here. Okay, fractional distillation is using fractionating column, and then you put I put over there lower MR, okay, lower relative molecular formula, okay, uh, lower the boiling point, okay, and then more volatile, and it is collected at the top. Okay, so it means if you have if the molecule is small, okay, don't have a lot of carbon, you will have lower boiling point. Okay, more carbon means more boiling point. And if it is going to be lower boiling point, we call it volatile. Okay, it can change into gas easily. Okay, that's the meaning of volatile. Okay, Jordan, can you still hear me?
Can a bit, but still quite choppy, sir.
Okay. Okay, I'll continue. Okay, if it is choppy a bit, okay, just bear with it because okay, I think the connection issue. Yeah, but anyway, you can refer to the notes. Okay, if it is important, I will just write it down. Okay, you see the short chain. Okay, let's look into the the concept. Okay, MR, lower boiling point, more volatile. Which one collected at the top and so on. So if let's say for example, I'm talking about short chain and long chain. Okay, for example, if I'm talking about butane, okay, versus heptane, okay, which one is longer over here? Jonathan, which one is longer, butane or heptane?
Heptane.
Okay, heptane is longer. Now, heptane has higher boiling point or lower boiling point, Jonathan?
Is it higher?
Yeah, it is higher. Why? Okay, because it has more carbon. Okay, if you have more carbon, more MR, basically your van der Waals forces will be greater. Okay, because of that, your boiling point is going to be greater compared to butane. So if your boiling point is greater, okay, so Dylan, I just want to know, where do you put in the position what if let's say this is going to be your fractionating column and this is position number 1 at the top, number 2 at the bottom. Where do you think it will be collected? Heptane.
Number two.
Yeah, very good. Okay. Heptane has higher boiling point, so they are going to be collected at the bottom. Okay, at the bottom. So I want you to use the same concept over here. Now, okay, that is going to be short chain versus long chain. Okay, different number of carbon. Let's look at the same MR. Okay, same MR. But this is the one that I taught you last week. Okay, same MR, but now you have chain and with branch, another one don't have branch. Okay, so butane is going to be straight, okay, 4 carbon, and then methyl propane is going to be like this. So I just want to know, okay, Kiara, which one do you think will have higher boiling point, butane or methyl propane?
Butane.
Again,
Butane.
butane. Okay, good. Why? Why this one has a higher boiling point? Kiara?
Longer carbon chain.
Okay, longer carbon chain. Okay, but I think you need to explain. Okay, you need to explain not only just because it's longer carbon chain. You need to explain because there are going to be more surface area. Okay, more surface area. So if you remember, I taught you about this. Okay, it looks a bit oval. Okay, so if you have more surface area, okay, more point of contact. Okay, more electrons, okay, can be arranged in that side. So van der Waals forces will be greater. Okay, compared to this one is going to be spherical. Okay, so there will be less surface area, point of contact. Okay, there is going to be less boiling point. Okay, so here the boiling point is higher. Now, okay, I just want to check with you butane and methyl propane. Jordan, if it is butane, where do you think is going to be collected? Position number 1 or position number 2?
Butane.
Yes,
The same one? Um,
yes, okay.
it's two.
Yes, 2 because okay, boiling point is higher. Okay, boiling point is higher. Therefore, they are going to be collected at position number 2. So that is going to be if they ask you about this. Okay. Now do remember I'm focusing on boiling point. I'm not talking about the melting point. Yeah. So if you look at the melting point, that's going to be the lesson last week. Okay. The melting point of butane, okay, is going to be lower, and the melting point of methyl propane is going to be higher. Okay, I hope you understand about that. Okay, if you're not sure, please refer to the video that I've made about last week, yeah, about this. Okay, anyway, okay, now we just compare. You have MR, the same MR, but we are talking about stereoisomerism. Okay, cis and trans. So I just want to know which one is cis, which one is trans. On the left, Erlin, which one is it? Which one is cis over here? Left or right?
All right.
Okay, so this is cis, this is trans, and they have the same MR, it's the same molecule. Okay, so I just want to know, okay, which one between this, cis or trans, will have higher boiling point. So James, can you help us in this? Which one do you think will have higher boiling point and why?
Trans,
If trans, why?
because
Read again, yeah, James. Okay, read again. Maybe Davis, can you help? Which one have higher boiling point?
Cis.
Okay, cis have higher boiling point. Why is that, Davis? Something to do with polarity. Okay, if you look at the CH3, so you can just say that, okay, this CH3 is going to be, maybe there will be more delta positive here, and then there is more delta negative here, so it's imbalanced, but this one will be cancelled. Okay, the polarity will be somehow will be cancelled, and it will become less polar. So it means that cis is going to be slightly polar. Okay, cis is slightly polar. So because it's slightly polar, okay, you are going to get the boiling point to be slightly higher compared to the trans. Okay, so this one is related to polarity. And do remember for melting point, it's going to be different, yeah? Okay, for melting point, okay, I'll just draw a little bit over here. So maybe if you have cis, okay, it's going to be arranged like this. Okay, if you have trans, it's going to be arranged in this way. So which one is more compact? This is more compact. If it is more compact, you are going to have more energy to break them into liquid. So it means the melting point is higher. But here, the boiling point here is higher. Boiling point is lower. Melting point is lower. Melting point is higher. But in this case, I am looking for boiling point. So I just want to compare cis and trans because cis has a higher boiling point. Therefore, cis is going to be at position number 2 also. Okay, if they ask you to compare, okay, which one will be collected first, which one will be collected at towards the end. So that is going to be how you differentiate. So this one we already done it earlier. So I will just move on here. Okay, so let's move on.